My name is Omer, and I'm really happy to be here. And I think it was yesterday, all the money we were able to donate so far to World Health Organization. So huge shout out to all the organization and to everyone who donate and help us make the world a bit safer. I do hope that at some point we'll have slides, but I'm not very optimistic about that. So continuous hacking, this is what I wanted to talk about today. And it's a bit an interesting talk name. And to explain why we need continuous hacking, let's start with, well, we can call it funny. In Israel, we had election like 2 months ago, and the company does something that could be smart. They give private companies access to all the voter database, and of course, someone leaked this database, and it gets even better because they were able to leak it 3 times, not once. It's really amazing they were able to do something so bad. But I'm not here to talk about what they did wrong. I want to talk more about what we can do so such a mistake will not happen to us again. Um, and I think this is the only thing we should take from stories like that, because there are always mistakes, and such mistake could happen to us if we're not try to become better. Now, if you're familiar with application security, there are a lot of things we can do to become better and ensure that things like that will not happen to us. And one of the things we can use is automation tools. And this is why I like to call this talk continuous hacking, because it's not a talk for application security experts, it's a talk for developers. And it's a talk for developers because, as Jim Honeycode said, and there is a really good tweet of Jim Honeycode that you can see right now, saying that, in my experience, all developers are security engineers. All software developers are now security engineers, whether they know it, admit it, or do it. Your code is now the security of the org you work for. And I really agree with this tweet because, after all, this is the code we write. And if we will not ensure that this code stays secure, we will have security issues. On the other hand, we are developers and we don't always know what we need to do in order to make our code secure. And this is where automation can come really handy. And I'm saying all that because, like you asked in the start, I'm kind of a chimera. I started as a developer from a really young age. I like to build stuff, and I was a developer for a very long time. And in the past few years, I did the shift to the dark side, to the worlds of DevOps, application security, and all this fun stuff. And now that I come from both worlds, I can understand them better and know how to talk with each other. And this is where continuous hacking comes from, taking the world of application security to the world of developers or DevSecOps. How we can use the tools we are using to build stuff, also to hack them. Just a second. So the idea is to have checks on each PR, whether you're using GitHub or GitLab or whatever you're using, and then run those checks on each PR we are using. And I'm going to show today three tools: the Snyk, Node.js Scan, and OSZap. And we're going to see how we can integrate those tools into the CI pipeline and how we can use them to build more secure software. So to start, we need just a second. We are trying to reboot the slide without stopping the show. Okay, so for the purpose of the talk, we are going to use a victim called JuiceUp. JuiceUp is a project by OWASP, Open Web Application Security Project. And OWASP does a lot of cool things to help us build more secure software, including creating purposely vulnerable applications like JuiceUp. And you can use JuiceUp for a lot of things, including wait a second, I think I can do that. Yay, we have slide. Okay. I think I never did something so bad as showing my slides via a iPhone camera.
Omar, I think if you can flip the camera, the camera is upside down. Yeah, the camera is upside down.
Oh, this one?
All right, yes.
Yes, okay. So now we can see the slide, which is somewhat better. I think it's when the talk where my Mac had episode during the talk. Now it doesn't want to boot. Oh, it wants to boot. I don't know. Anyway, so this is JuiceUp. And to go back, this is the tool we are going to show. And this is the goal, to have a PR with all the security tests in it. So I think we need to move fast because I'm almost out of time. But we're going to start with dynamic security testing using another tool by OWASP called ZAP. And basically, it's the idea to put ZAP between a client and the server, use it like a proxy, and let it inspect the traffic. And we can use existing end-to-end test for this. This is an example of how to do this with Selenium. So basically, each time our end-to-end test run, it will go all over our application and proxy them to ZAP. And we will end up with this. This is a live from Circle. The ZAP find an issue, and we can look into the issue. Let me see. I don't think I have enough time to go into what the issue, so we are going to go fast over this. And move to the next tool, which is static analysis. Static analysis is basically automated code review. If you're looking for a tool, there is a really good website called Compare, which has a list of a lot of amazing tools, and you can look on them by language, what they can do, license, and stuff like that. So if you're looking for a SaaS tool, you can check it out. Today, we are going to focus on one tool, Node.js Scan. We are going to give it which directory to scan and where to save the report. And now we have the report, and we need to fail the build, which is a problem because Circle CI does not understand the output of Node.js Scan. So it cannot fail the build if Node.js Scan will find an issue. And for this, we are going to use another tool called Glue, which its purpose is basically glue security tools into the pipeline. So here we are giving Glue the report from Node.js Scan and how to read it. And now the build will fail each time we will run it. And you can see that not like before, we now have exactly where the issue is and what it is. And again, because of time, I'm going to skip on what exactly the issue is and move to the last tool, which is packaging scanning, Sneak. So we all use a lot of packages because it's a lot more cool to use a code that someone else writes. But the fact that it's a code written by someone else, it does not mean that this code does not contain security issues. In fact, this is a code we are usually not scanning and not reviewing. We just download it from npm or Nugget or whatever, but we cannot know if one of the packages is vulnerable. And this is some slide from Snyk Open Source Security, a really interesting report. I think they're now working on a new one, and we can see that the number of vulnerabilities keep rising, and it's even more problem when talking about environment like npm, because most of the dependencies come from indirect dependencies. So I don't know if you're familiar with this thread, but this is a thread where everyone posting images of dependency graph of all the packages they're using. So this is what happens when you install React. You get a lot of other packages. Now, I imagine one of the points in the end of the graph has a vulnerability. It still affects your code, even if it's a package that you didn't install. And this is why you want automation. And Snyk, the best part about it is that it's really easy to integrate it. You just go to their UI and you get it immediately. You can see all the result and you get the PR check, which is not like the tools I showed before where you have some manual work you need to do in order to make it happen. And now we can look on the vulnerability, and we have a nice fix this vulnerability button that open a PR for us. And this is a really funny one because someone here tried to mitigate XSS with a sanitization library, but this sanitization library had XSS bug in it, which is pretty bad. So I'm not going to go into it because we don't have a lot of time. And I think it's time to start wrapping up and maybe open up to questions and go back to the slides in case you missed something. So this is where I wanted to start. And I hope now you have somewhat better understanding of what those three failed tests, why they are important, and how you can add it to a pipeline. And to summarize, Snyk is the easiest one to add, but it just can code it of the other. It just can code others' work, not your code. Node.js can, which is a bit easier, it just can your code, but still requires some manual work. And Zap, which is a bit more valuable, but is the hardest to use because you need to configure your end-to-end test to proxy through Zap. And there is a link here to a blog post I wrote summarizing all the things I talk about in this talk. And this is the quote I started with. And I hope now you know how to do security a bit better, because now it's your move to choose one of those tools and try and hack your application. So thank you very much. And I think we have enough time for questions. I lost a bit track of time.
Yeah, we do. Thank you very much, Omar. And thank you for trying to make the presentation work regardless of the failure. So while we wait for the question to come through, a quick question from myself. So from a security perspective and from a developer perspective, what made you effectively jump the fence to the security world?
It actually happened pretty much by, like, I can tell it my initiative, but my company started I agreed, and it was like 4 weeks ago. I did a pen testing course, and from then I get into application security and recently into DevOps, and I really enjoying this journey.
Fantastic. And you mentioned between the two that there is a one to integrate, but maybe could you mention the one for team that doesn't have a budget and the one for team that have a small budget? Because the good part, I think, for WASP is that if you don't know where to start and if you don't have a budget, those tools are free. And even if they're not maybe the smoothest to integrate, they're definitely there to improve the success, and also you can spin it off.
Wait a second. Wait a second. You are a bit. Can you start again? I didn't hear that.
I'm just saying, from a security perspective
Can
and
you ask again the question?
from a cost perspective, which one would you recommend for a team that doesn't have a lot of budget from a security perspective?
So this is a really great question. This is why I added this table. It's really hard to answer because budget has two parts. The first one is actually dollars you have to pay for a tool, and the second one is time. So money-wise, Snake is the only one here which costs money, but they have some. They have different offers, and it's free for open source. So it's the best to talk with them. And of course, the open source alternative, OWASP, has a tool you can use for free. Discount the dependencies. The last column here, the ease of use, is the one aimed to answer more about time. And there is something that I didn't edit here, which is, I think we can call it false positive rate, because you cannot run these tools if you don't have someone in the application security team who is willing to invest time in helping developers to figure out why the tool reporting something which is not interesting. So there are a lot of aspects to pricing. So it's a bit hard to answer that, but I think the best thing I can say is that it's not plug and play. It's never plug and play, and it will never solve all your issues. But if you want to start, the thing investment is packaging, because this is the thing has the least number of false positive, and somewhat easier to start. From my experience, static analysis has a bit more false positive and not always give good value, depending on the tool. And dynamic analysis is usually good, but is a bit hard to set up.
Yeah, I agree, and also to interpret. And I